our seminar. And so we don't delay stuff, I would like to introduce our guest. It's Richard Chow. He's a university research director and scientist at the Intel Corporation. He had quite a number of posts before. He had positions at PAR, with Yahoo, Motorola, and his work concentrates on privacy, big data, mobile, and the cloud. And he has a lot of patents, publications. He is a runner-up for the 2010 PET Award for Outstanding Research in Privacy Enhanced Analysis. And, he has given many invited talks in many places, and he has a PhD in mathematics from UCLA. So, and today will be about the last mile of IT privacy.
Thanks, Alex. Is everybody can hear me okay?
A little bit louder.
So, I know that it's recorded and there's some kind of devices to record it.
The microphones are all built in the seating, so they won't pick up this.
But is there like reinforcement?
I'm sorry?
I mean, speakers.
We don't have. Well, we do have speakers for the videos that you play, but not for the speaker.
No.
I see. So I just have to project a little bit. Is that okay?
There you go.
Okay. So thanks, Alex, for inviting me today. So the topic is IoT privacy. It's kind of an old topic, but the point of view that I want to bring to it is sort of more from a user-centric privacy. And this is more a talk about problems rather than solutions. Okay, so I'm not going to give a lot of answers. It's more like a survey. So hopefully this will be interactive, so you can feel free to chime in with your own opinions or comments anytime. So I just want to start off with a little story. A couple years back, the family and I, we were coming back from vacation in Hawaii. We're going to the Bay Area where I live. We were transiting in Honolulu. Okay, so my kids at that age, they had these little roller backpacks. You know, they got off the plane first and they decided to have a little race. So each of them had one and they just ran off the plane, ran to the terminal, and I thought, okay, no problem, I'll catch up with them. We're going to make a connection to go back to the mainland in the terminal. So I walked down the terminal, couldn't see them. I looked at the place where you go to the baggage claim area, you know, where you get out of the secure area. Asked the people there, hey, did you see two kids with roller backpacks? No. All right, so then I came back, did another sweep of the whole terminal, didn't see them. So I was getting a little worried because the plane was leaving, and we had just 1 hour for the connection. Eventually we got security involved. Hey, we're looking for two kids. And the funny thing is when I called them, they said, oh, yeah, we found them. This was because somebody else had already called earlier about a different set of kids that were lost. Okay, so, okay, let me stop a second while these guys.
This is nice.
Some people at first sight.
Yeah, this is the first time I've heard this.
Okay, so to continue the story, we got airport security involved, and they eventually found the kids. They suggested maybe they really are in baggage claim, so they went down there, and sure enough, the kids were there in baggage claim. So I had to go into baggage claim, get the kids through security again, and we caught the plane. But you would think that an airport terminal, this would not be a problem. There's so many sensors, cameras. If you would think that you would be able to locate somebody fairly easily, you know, if you really need to locate somebody. But they couldn't, right? The police had to go around and manually check it. So this is a talk about privacy, yet I just want to give you the story because just to emphasize that, you know, privacy is not everything, right? There are a lot of services that would really be useful that may be a little difficult now because of privacy concerns. But on the other hand, I think they will be coming in the future. Okay, things like a kid finder. And when I tell, I told a lot of my friends after this trip what happened, they all said, yeah, it happened to me too. I mean, every parent loses their kid at some point, even though they might not admit it immediately. Okay, so now to go back to the subject of this talk, if you look at a typical urban environment today, and you're walking in the street, you might have a lot of access points in the area. You might have, street cameras for security purposes or other purposes. And maybe in the near future, and in some places even now, you have sound monitoring devices in a smart city. I mean, maybe you will have the kid finder. Or you have gesture recognition things, and maybe heart rate monitors in your gym. If you can monitor somebody's heart rate, and you can do that through cameras, just from the skin tone, by the way, that would be really useful to prevent people from maybe doing too much. So this is all good, and a lot of the problem is a lot of these things you may not know exist in the environment. So Wi-Fi access points, you can probably find them. Street cameras, the only way you really know is if you can see them and they put a sign there. Some of these other services, you have maybe no way to know that they exist in the environment. If somebody's taking a picture with a smartphone and you happen to be there, you have no way of knowing that either, right? Maybe you're not bothered by that because you think it's a public place, it's okay, but maybe you would be. But it'd be nice to know about these things. In your house, you would think in your house, you sort of know what's going on, what devices are collecting what types of data, but it's not necessarily true because things are hard to configure, and of course, there might be malware. So all these things point to the fact that there's sort of kind of a transparency problem. And this is the bottom line problem for privacy. You don't know what's going on in the environment. You don't know what's collecting data. You don't know what they're doing with the data. You know what inferences are being made. And I would argue that this is different than the old traditional, PC or smartphone. Because for a PC or smartphone, in theory, you control the environment, so you know what's running. In theory, I know it's not exactly true, but in theory, you have the applications that are running, and you can sort of look at them, and they sort of tell you, in theory, what they are doing and what data they're collecting. And I know there are a lot of things that are not quite right there, but at least there's a way to proceed and a way to sort of know what's going on. But in this new world of IoT devices that exist in the physical world that you're in, there's no such way. There's no natural communication channel with these devices, right? So I think that's a big difference, right? So part of this talk, right, is to sort of outline a sort of a way to proceed from these IoT devices to something that a human can actually understand and know what's going on. So that's sort of the point of this. And to do this sort of path from IoT devices to humans, I want to talk about a privacy stack. This is not a protocol stack, it's more just a conceptual stack. And you'll see what I mean for moving from IoT systems to humans. So the first thing in this privacy stack is awareness. So let me try to explain what that means. So personal data collection should happen with knowledge and consent. So this is one of the basic privacy tenets that we have. So way back in the 1950s, the US Department of Health and Human Services started to have these databases full of health records of people, and they realized that we needed some common rules to deal with privacy of these people. So they came up with what's called the FIPS. And I think that stands for, I don't even remember what it stands for exactly. Federated Information Privacy Principles or something like this. Anyway, it's the one of the first set of privacy principles that people had to deal with data. And this is maybe, you could argue, is the most fundamental of all of them, right? Basically, if somebody's collecting your data, you should know about it, and you should be okay with it, okay? These FIPS, it's funny, these FIPS aren't really a part of US law currently. I mean, some states have privacy regulations, but we don't, in the US, we're not really big on privacy laws. But Europe went really big on privacy law, and these FIPS became the fundamentals for European privacy law. It eventually became what's now called GDPR, General Data Privacy Regulation that they're talking about in Europe. So, but at any rate, this is, even if it's not sort of part of our legal system, it's kind of a general policy people like to follow, even in the US. Okay, so
But is there a definition of personal data?
yeah, we'll talk about that. Okay, so that's maybe the fundamental question of what this means. Okay, so in the U.S., different states have different interpretations of what personal data means. An IP address can be considered personal data. Some people consider it personal data, some people don't. Right? And it's murky, it's very murky. The way the Europeans define personal data, so personal data in the US, sometimes you see PII as another way to say personal data. In Europe, they call it, I think, personal data, personal information. But the definition of personal data is generally, it just means data that you can tie to an identified individual. So what does that mean? So it seems like we're just pushing the definition to what's an identified individual. So an identified individual, you could say somebody with a name, okay, or some kind of ID, a credit card. But anybody that's identified in that way, any data associated with that individual is considered personal data. So the fact that this person likes ice cream, for instance, you would think, well, that's not too personal because half the people in the world probably like ice cream. But the fact that it's associated with a particular person, that becomes personal. And even if it's not considered by you to be private, because it's very innocuous, it should be up to each individual what he considers private. Right? So that's the basics of privacy. I mean, what I want to release to everybody else should be up to me, not anybody else. So that's the definition of personal data. Okay, so this legal framework, this personal data should happen with, collection should happen with notice and consent. For regulators, it works pretty well and has worked in the past. So when you go to a website, there's a privacy notice there of what the website is going to do, and describe, how long it's going to keep the data, what it's going to do with the data, things like this. So regulators look at this and say, okay, you better do what you say you're going to do, and if you don't, they're going to come down on you. So this works great for regulators, except for normal users, nobody looks at those things, probably. for the most part, right? Who looks at Facebook privacy policies or Twitter privacy? I don't know if Twitter has much of a privacy policy, but for instance, nobody really looks at those things, right? So that's the situation with traditional notice and choice. I would argue that when we move into the world of IoT, it becomes much worse, the problem, because how do you give notice? If you go to a website, you can give notice because there is sort of a place you can find a privacy policy, and you sort of know you're on the internet, right? So you know some data collection is potentially taking place. In this room, until Alex just told me, I had no idea that this might be recorded. Now, how am I supposed to know that? I don't know, right? So notice in the physical world is something that is difficult, right? Without some channel to tell me that. Choice, right? How am I going to tell the system, hey, I don't want to be recorded? I have no idea how I would do that, right? The only way I would do that is somehow interact with somebody who controls the system. Very difficult, right? If you're in public walking down the street. In other words, the interaction mechanisms are much more difficult than, say, going to a website. Okay, so this is a different kind of world where things are more difficult. Right? That's my point. Okay, so that's the legal and policy side. Another aspect of awareness is that, sociologists, and this Judith Donath is a sociologist from Harvard, she's saying, we've got to design spaces so that people know that they're being surveyed. Because you act differently if you're being surveyed. If we're having a conversation, Alex and I know there's a microphone going on, I might be a little more guarded in what I say. Right? It's natural and makes sense. So since we're all go in and out of public spaces and school and home, we all sort of have this idea whether what's happening is being recorded or not. And if we live in a world where we don't know whether it's being recorded, what do? We have to default to the assumption that we are being recorded. That is natural, right? If you don't know, you have to assume the worst. At least that's what I would do. Therefore, the fact that we don't have this communication channel with IoT devices, we don't know what's going on, we have to assume there's recording going on all the time. And so we're going to act differently. And from the point of view of society, that's, I think, changing, right, how we act. Okay, is that good or bad? I don't know, but all right. So that's the sociological aspect. So technologists have picked up on this, of course. So Jason Hong is a sort of a privacy researcher at CMU, technologist. So his thing is, okay, well, this is good. So therefore, we have to figure out how to design technologies so that when we walk into a room, within 30 seconds, we can figure out what data collection is taking place. This is one of his grand challenges. So he has some interesting projects going on at CMU. So for instance, maybe there's some little robot in the room whose expressions sort of, or what the robot is doing, tells you what data collection is taking place. So for instance, a robot that's doing something with the ears may signify to people, hey, audio recording is happening. And he tells the story that he was teaching a lab course for one semester at CMU, and only during the last part of the course did somebody tell him, hey, did you know this course is being recorded? He didn't know until that point. Okay, so that's what awareness means. Okay, just being aware of what's going on. How do we accomplish awareness sort of today? Well, we have these signs in the environment, okay, and we have some IoT protocols that sort of are discovery protocols, so they're sort of meant to be discovery protocols about what IoT services are available. But I would argue, you know, these protocols don't really do enough for privacy. So they're meant, they're sort of that's not their main focus. I think they could be enhanced for privacy, which is what I would advocate, or different things need to happen. So I don't know if people are familiar with iBeacon. iBeacon is just basically, so it's from Apple. It's basically a little Bluetooth emitter. So you put it someplace, say a museum display or a store display, and it shoots out a globally unique ID. And then on your phone, you have an app which basically takes that ID, shoots it up to the cloud. The cloud does a lookup of that ID and says, oh, you're near this museum display. Here's some information about that museum display. It's useful because you can get information about what you're near, or you can get an ad, or a coupon for the store you're near, or things like this. On the surface, it looks like it's privacy preserving because it's just an anonymous beacon. It's just sending an ID, but the problem is the app sends that ID up to the cloud, so the cloud knows you are near that beacon. So it sort of gives away your location potentially. But it doesn't really tell you about privacy problems. Intel is actually associated with both W3C and Open Connectivity Foundation. They're trying to build standards for IoT and device interaction. So far, there's not really much there yet on sort of privacy metadata being exchanged. But it could be put in there. Okay.
But all this could require some active, if it's active measurement. Like, I mean, maybe you lead in that later. If it's somebody is taking picture and has no relationship to this environment, like the one that's showing next slide, or like the dash cameras, like, is it even feasible to have any kind of awareness of that?
Yeah, that's a good question. I mean, it would have to be in cooperation with this guy. Maybe. Oh, let me go to that picture. So what Alex is talking about is, you know, this is all great, and but there are use cases like this where you may be in a picture of somebody taking a picture on the street. And there even may be, so I know I said before that in theory you know what's going on your own phone. Okay, everybody knows that's actually false. Okay, so because that's false, there may be something going on your own phone that you want to like stop, right? Just like people put a little blocking sticker on their laptop because they don't know whether the camera's on your laptop. It'd be nice to know that the phone is actually recording audio or video or whatever at any time. So some signal to the user. So I think in that case, it's probably not easier to get a signal to the user, but if somebody else is taking a picture of you, it may not be so easy. But you can imagine a cloud service where maybe the camera signifies to the cloud service, okay, in the orientation. So this is getting much harder, right? But the picture is taking place and you get a notification, hey, somebody's taking a picture of this road.
That could make it even worse because all pictures that we have to go to the cloud.
Well, not the picture itself, just the notification. And the picture could go too. There are various ways we could do this, right? But just a notification that if you care about pictures in this environment, let me know. And then this will say, okay, of course, there's some impractical aspects to this, but.
So I have a question about those protocols that you mentioned, like little bit ago. Like for example, the IBCAN or MDNS, right? So if you want to make them privacy aware, so couldn't you disrupt their functionality for the purpose of those protocols?
Potentially, but so making these protocols privacy aware is going to incur a cost. It's going to incur potential usability issues, right? Just like security, there's going to be a cost.
Yes.
Do we want to incur those costs? Some people would probably say, okay, yes. Some people would say no. I think part of the system is we have to accommodate both preferences. Some people, you can take a picture of me anywhere, you can record me anywhere, I don't want to be bothered, okay? But some other people, I think the personal preferences are very important here, and we have to accommodate them.
Some of the functionality is like very fundamental that you cannot skip those functionalities like MDNS. You're resolving the name to IP address. So some protocol needs to be there to solve that purpose, right? So
So we have to. I'll talk a little bit later about some system level picture, but yeah, we have to introduce new protocol, new systems. So it's not going to be too easy, but I think something needs to be done. is my point. So we just made it this far. Basically, awareness. We've got to know what's going on in the environment. But the next question is, so what if we know what's going on? And let me try to explain that. A long time ago, when I was at Park, we did a user study. This is just when the iPhone just came out, and we were collecting data from people. And we asked them, is it okay if we collect your location? Most people just said, yeah, okay, sure. And then in the interview at the end, we sort of explained to them, hey, did you know from location, we can sort of figure out where you live, where you work, and therefore we can figure out who you are, basically. And they said, oh, okay, in that case, no. I don't want you to collect my location. Okay, so I think today, I think probably most people would realize location, from location you can infer identity and behavior and things like this. But way back then, no, it wasn't so obvious. From a lat long trace, it wasn't so sort of obvious to people you could infer these things. So
that's a very good point. I mean, having known the location, at least you can sort of profile where it is coming from, right?
we could know where the guy is.
Yes. Okay. So now, if suppose the person is continuously changing the location, he's here, there, one there. So how do you sort of trace the authenticity of where it is coming from?
Yeah. I'm not talking about the somebody trying to fake the system by sending false data. So right now I'm just talking about we're just collecting data in the normal sense, and that's a way to potentially enhance your privacy by injecting false data.
Right.
But right now I'm ignoring that for now. I'm just saying that from data like GPS data, you can infer a bunch of stuff, which now I think everybody realizes, but before it wasn't so obvious. And I think the same thing is true, from other types of raw data. Okay.
There's a famous Netflix study where they just exposed reviews, like ratings, and people using external data sets, they just import who we did what.
So that is an esoteric example. So basically, movie preferences implies identity. I guess I won't describe exactly how that happens, but there's a famous paper which has that inference. So on the left-hand side here are various kinds of raw data. Okay, you can imagine a MAC address, video, audio, or various kinds of sensor readings. And on the right, you have like, well, what that raw data can infer. You can infer heart rate, or even not just heart rate, but your EKG pattern, which is identifying. You can infer whether you're walking and running, what kind of activity you're doing. You can infer location, as mentioned. You can infer all these things. So when we're doing awareness, where we're telling people what these systems are, what data they're collecting about you, do we give them the raw data, or do we tell the user the raw data that's being collected, or do we give users the possible inferences? And that's a difficult thing, because the possible inferences are infinite, basically. Another example we're just talking about this morning with a couple of people is power data, electrical power data. So you can put over here smart meter data. How many people would realize what it inferred? Maybe a few people. I'm not really sure how many people would realize the consequences. But I guess the issue I'm bringing up is that there's raw data and what it infers. And the set of inferences from the raw data is continually growing. Even privacy experts have a hard time keeping up with all the inferences. So GPS and mobility traces we talked about gives you identity, and electrical energy usage gives you, whether, at the very least, gives you whether you're in the house or on vacation, but it can give you what time you take a shower, what time you eat, what time you use the dishwasher, what appliances you use, all these kinds of things, which you may not realize if they just tell you electrical usage data.
So, in the raw data, you don't consider the ambiguity in the data, or the precisionness, or maybe inconsistency in the data. Would that affect the?
Yeah, that affects the inference,
Yes.
or the confidence in the inference.
Yes.
But I guess my point here is that people don't necessarily realize that this is a possible inference.
I see.
And because they don't realize it, they may say it's okay. Just like those people were okay with location before they realized the consequence. So here are some things, like accelerometer data. Would people be okay with collecting your accelerometer data? And why not? Question for you.
You can also tell if he's standing or he's moving, going somewhere by the accelerometer data, right?
Yeah.
So you can infer where it is when he goes to the work, when he goes to
Okay.
back home.
It can give information on diseases, for instance.
Oh, diseases. I haven't heard that one.
Well, yeah, the Parkinson's disease, for
Oh,
instance,
okay.
they're measuring
Okay.
accelerometers.
They can know like how often people travel on the highways, if the speed is like high, like interstate travel.
Okay.
They can know about like travel to the between cities.
Okay, good. So we're full of inferences. Another one is
They can also get your gait pattern, like how
Yeah.
you walk.
your gait. So you can identify. So gait is an identifier, basically. So accelerometer traces basically can identify you. Okay, so we have all sorts of things from accelerometer. So you guys are all up on that. Biostatistics. Okay, so now we'll move to more esoteric things. Ambient audio. So if you're speaking on the microphone and the background noise, it turns out can identify your location potentially. I don't know if you've seen the movie. There's a movie where this guy was calling the police, where he was calling the police from different locations, and the police only had like 15 seconds to trace the call or something, so he would hang up before that 15 seconds was up. But eventually, the police noticed, hey, there's a subway, there's a train in the background or something, and say, oh, that guy must be there. Okay. So in the same way, ambient audio is you can infer location from ambient audio. Hey, this guy is calling from the same location as before. Whether that's good or bad, I don't know. Ambient light. What videos you watch is very private, actually. You can ask Robert Bork. There's actually a law that was inspired by the Supreme Court. I don't know if you guys remember that one. But anyway, what these researchers did, and this is now going to the research realm, is that when a video is playing on a TV screen, it's basically a bunch of flickers. Now, on a smartphone, there's an ambient light sensor. That ambient light sensor needs no special privileges, at least on Android. This is different from the normal camera, which of course you need privileges for. But the ambient light sensor is meant so that you can tune your app. If it's dark in the room or if it's light, you can sort of adjust the light level. And there's no danger in knowing what the ambient light is, right? But you put this smartphone on your coffee table, and you can sort of, from the ambient light sensor, you can sort of tell the flickers from the TV screen. These guys demonstrated that from those flickers, you could figure out what video you're watching. So therefore, an app with no privileges can figure out what video you're watching in this kind of scenario. Okay, so this is another unexpected inference, right, from ambient light. From gyroscope. Any thoughts about what a gyroscope like? Well, it turns out that from gyroscope traces, you can they sort of distort the air, sound waves distort the air a little bit, and from the gyroscope traces, you can sort of figure out what somebody is saying. And you don't really need special privileges to measure a gyroscope, again, on an Android app. And it points to just a general thing that when you take a picture, I mean, you measure data with a physical sensor. Because it's a physical object, that thing has imperfections. And it's different from every other sensor of the same type. Because of that, something produced by that sensor, like a picture, is going to be unique. So you can say, oh, these two pictures came from the same camera. So I don't know if you guys, this wasn't a movie, this was actually, they figured out when printers have this, as not by accident, but actually as a design feature, you can figure out that a particular printer printed the same paper because they embed a particular code into the thing. So I'm saying the same thing, except even if they're not trying to do that, it's done anyway for them because every physical sensor is unique because of manufacturing, because it's a physical thing. So finally, power usage. When you have a smartphone going down a particular street, the amount of power that it uses to connect to the cell tower is changing, depending on what's obstructing your sort of path to the cell tower and your distance to the cell tower. So it turns out that if you're going down a street, how much power you're using is varying in basically a unique way depending on the street. So therefore, from the power trace, which again, you need no special permission in Android, you can figure out where somebody is driving. Again, a little bit an unexpected inference. Okay, so I think I've belabored that point enough. We sort of, at this point, we know we have to be aware of what's going on, and from what's going on, we need to know what inferences are possible and somehow convey those. I haven't told you how to do it. If there's time, we can talk about ideas on how to do this. But so after we figure out what possible inferences there's still the issue of people are different. some people don't care that your location may be, leaked. Some people say, yeah, I really want to know, and I don't want that to happen. So how do you take that into account? As you know, this is really difficult to get privacy preferences out of people because, Facebook has tried to do this for a long time, and you could argue they're not really trying. But giving them the benefit of the doubt, they're really trying to do the right thing and trying to get what people really want. It's a really hard problem to sort of figure out because there's so many parameters, right? Figure out what people really care about. But again, I would argue for IoT, it's a much harder problem of what people care about. And the reason is because there's so many different factors. Okay, so one thing is who is collecting the data? So this camera that's collecting video right now, is it being collected by the university just for the use of the computer science group, or is it collected going to be by the government, or who is actually collecting the data, or maybe an advertising agency? All would probably cause people to have different reactions. Okay? And so it's important who's collecting the data. It's of course important what the data is. And it's also important, where you are. So maybe in this classroom, you're absolutely fine with collecting the data. But you're probably not so fine maybe at home. And maybe different rooms in the home would have a different you might have different attitudes. So where you are, who's collecting the data, what the data is, and even the time of day. If you're at work, or you're at home, or you're in public, everything sort of matters. Who you're with. If you're with your boss, okay. If you're with just your buddy, it's different, right? All your attitudes. So all this context sort of influences people's attitudes toward data collection. So how do you deal with this problem? Because you can't just ask somebody, all right, here are all the possible situations, how do you feel about this, whether you want to know about this or not, because there's too many to list. So one idea is to sort of use machine learning to classify people's attitudes. So basically you want to model people. And if people fit into certain clusters, like a few different clusters, you say these are the guys who don't care about anything, these are the guys who care about everything, and these are the guys who care about this, not that, and there are a manageable number of clusters. Then I think you're in business, right? Because you can set those as your defaults, right? And then you can let the user tune it a little bit as to what he really wants. So we worked with Professor Alfred Kopsa, who's at UC Irvine, on these kinds of ideas, privacy decision making. He was trying to figure out what factors really influence users. So he came up with factors that people really care about, and some others that they care about less. And his goal is to sort of build some kind of system which would help users.
So on your data, if we can sort of make a classification like structured data, unstructured data, right? So then you could sort of relate your contextual nature of what you're trying to infer based on those data.
So give me an example.
Well, like for example, if I'm trying to collect the data in an unstructured environment, because the environment I don't know anything about it, I'm sort of doing a random, collection of data where I do not know anything about it, what I'm collecting, okay? So structured means, well, I know the data where I'm collecting, I know the surroundings and sort of what parameters and things like that I'm collecting. So that's the way I mean on the classification of data itself.
So do you mean maybe in the house,
Yes,
you generally
yeah,
know what's
yeah.
going on?
Exactly.
But maybe if you're walking down the street,
You don't know anything about it, yes.
So, yeah, I mean, so you could put any kinds of inputs like that into your algorithm potentially. I mean, anything's fair game in this, as far as inputs. Okay. Okay, so the last part of this is, okay, suppose you're able to know exactly what users really care about and what they don't care about, an individual user. The last part is, how do you actually notify the user? Suppose the user, you know this user really wants to know that there's a camera taking a picture of him at this point. How do you notify him? So, there are a few points here. Notification has to be a relatively rare event, because if you keep notifying people, like, they're going to ignore it. And it's pointless. Another thing is that this depends on the notification preferences from, I mean, things like Alfred Kops's system or other systems. You need to have some way for users to have preferences. And then there might be different kinds of interaction mechanisms. So for instance, I might not be looking at my phone when I'm walking down the street, right? Although I'm probably in the minority these days. If I'm not looking at the phone, but there's something that's recording maybe my MAC address, and I want to know about that, then I need some kind of beep. Right? I need some notification right now. But the other way to interact is that I'm looking at some device, and from that device I can figure out what's happening in the environment. So some kind of Marauder's map. If you watch Harry Potter, so some kind of screen where say, okay, here are the monsters, I mean services, and here's what they're collecting. So some kind of visualization of what's happening in the room. And that would also be very useful. And again, it's sort of unclear how to design this thing, right? But there are basically two modes of interaction that I'm putting up here, right? Notification, like a ping, or some kind of visualization of what's going on in the environment. I think both are useful.
There's also aspect of some action. Like if you don't, I mean, you get notified that something is happening and you want to do something.
Yeah.
But there has to be some way to enforce that I don't want my picture to be taken, blur me from that picture or something like that.
Yeah, ideally. Otherwise, if there's no way to interact, you could take action by leaving. Or at least you know about it, which is better than not knowing. You might guard your behavior. So yeah, in the best case, there's some interaction that you could say, all right, can you pause the recording? At UC Irvine, they have this, their sort of computer science building is instrumented so that each room has a way to sort of record, but also if any user does not want to record, then the recording is stopped. Okay, let me say a couple more comments. This is all not about security in some sense, okay? Because if somebody really wants to record you surreptitiously, they can. I mean, there's no real way to stop somebody from surreptitiously recording you. At least it's very difficult. It's sort of like a spy versus spy thing. In order to figure out there's no bugs or no cameras in this room is really difficult. And this is not about that kind of scenario. This is more about the scenario where there are companies or service providers trying to do the right thing and saying, okay, we want to provide an avenue for users to know what's going on, and here's how they would do it. Right? It's not about the bad service provider saying, I want to record you. Okay, thank you. And so this is more about social norms. So because it's polite to sort of tell people that you're recorded and tell them what you're. what's going on, and also about standards, right? So in order to do this, we need standards across various devices and standards for how data should be described, and basically lots of different kinds of standards. Does that make sense? Okay, so let me just quickly say, just the desired experience is, so the human would sort of be able to discover these surfaces in the environment, maybe using the phone, filter them for privacy mismatch. In other words, there's something in the environment you wouldn't be comfortable with, and then notify selectively. Okay, so this is the vision for this kind of system. You can imagine that this system can be designed, a peer-to-peer way. Right? So these nearby services, right, directly tell the human, maybe through a proxy, that what's going on, and he filters them. Or you can go to the cloud. Somewhat similar to the iBeacon model, right? So maybe there's a service ID that you look up in the cloud. The cloud has all the privacy metadata about what's going on. Then it sends it down, and then you sort of filter that based on what the cloud records about your service. So there's another possible architecture. So that's pretty much all I had. And then there are more details in IEEE Security and Privacy Magazine when this article appeared. So, just late last year. Any questions or comments?
So both the design, the architectural design that you have shown, they both have the limitations of existing architecture. Like the last one that you're going through cloud has the same limitations like iBeacon, right? Because that's the one that you begin with, that this is the motivation and this is the privacy issue, right? That you are going through a cloud, it could be like where your information can be leaked, or the privacy concern comes from there, that it's going through the cloud. And in the first design is that you are looking for peer-to-peer, and the problem with MDNS type protocols, that's the same concern that you have, right? Because there you're talking peer-to-peer, and the privacy issue is still there. So how come these two architecture, or will these two architectures solve those concerns that you begin with?
So, yeah, so in the end, the iBeacon and MDNS, they're not really motivating what I was talking about, because so iBeacon does have the privacy concern that when you use an iBeacon app, you're basically releasing your location to the cloud, and that's true. But I guess what I'm saying is people may not realize that. If they realized it and they're using the app, then it would be okay because they're sort of doing it with fully recognizing what's going on. So I would say that if we want to do that right, when they use this iBeacon system or this app, basically this metadata comes down that says, okay, by the way, we're releasing your location. Are you okay with that? And if he's not okay with that, maybe automatically this happens on behalf of you, then the cloud may not record your location. But if you're okay with that, then the cloud records.
So is it more like now cookies you can say do not track, or you don't want to be tracked in the website when they send the cookies, right? You can specify that.
Yeah, potentially. Right? So in other words, you have preferences. Maybe, okay, so there's a CMU is building a privacy agent on the phone, which is basically, your preferences are supposed to be incorporated in this agent. And so the idea is that this agent does a lot of the heavy work for you, so you don't have to pay attention. So then if you don't like your location being recorded, then the agent will do all the sort of bargaining for you, and then you don't need to worry about it. So the idea here is more. It's not so much saying there's a problem with one system, but just bringing a way to give user awareness for all these kinds of things. in a way for users to sort of interact with this world where there are all these different systems, right? Because we could figure out something for like, we could figure out, but it's all point solutions. But we got to figure out something for all these different systems, right? Because they're all trying to get data eventually. Any other thoughts? Comments?
Okay, so I guess inference is the most complicated part.